Welcome, everybody. This is the BioIT World Conference. I'm Kevin Davis, and once again, we're delighted to be joined or to have assembled a round table to talk about a variety of issues that I think impact everybody, if not professionally, then certainly personally. We're going to talk about the future of the present and future of personal genomics, and I think more broadly, personalized medicine and sort of the entire sort of healthcare ecosystem. All that in 50 minutes, everything you ever wanted to know. I've really delighted to be joined by four esteemed guests. Some we've worked and invited here before, some are new to us. So I'll introduce them. We'll get a few questions going just to get them warmed up, and then I hope that you will take advantage of this opportunity and we can take as many questions in the next 50 minutes or so from the audience as we can. You've been great so far, and you've been great in years past, so I hope you'll come and really take advantage of this. So let me just introduce these guys briefly in order. Closest to me is Jamie Heywood. Some of you at the Best Practices Awards dinner last night heard Jamie give a really powerful talk about his work. He is the co-founder and chairman of a company based here locally in Cambridge, Mass, called Patients Like Me, and we'll talk a lot more about that in a few minutes. His interest in this came when his brother Stephen was diagnosed with ALS, Lou Gehrig's disease, about 10, 12 years ago. Jamie and his family established the ALS TDI, the ALS Therapy Development Institute, which has done and continues to do groundbreaking research in ALS basic research and preclinical work, putting drugs into the clinic, and really making an impact in terms of treating a still very mysterious and still incurable disease. That story has been told in a book by Jonathan Weiner, a very acclaimed Pulitzer Prize-winning author, His Brother's Keeper. Also an award-winning, Sundance Award-winning documentary, So Much, So Fast. I urge you to buy the book, rent the movie, and we're going to talk to Jamie in just a second. Next to Jamie is an old friend, Kari Stefansson, who's been on this panel the last couple of years, but there's a lot new going on in Dietrich's life and career to want us to bring him back. Dietrich is the co-founder of Navigenics, consumer or personal genomics company, celebrating its second anniversary of the launch of its Health Compass genetic screening service this month, in fact. And more recently, he is the founder of the Ignite Institute for Individualized Health, and I certainly want to hear a bit more about that and the plans for that very exciting institute. Next to Dietrich is Kari Stefansson, former keynote speaker here at BioIT World. Ironically, the first and almost only European to escape the volcano in his local land of Iceland. Kari is, of course, as you well know, the founder of Decode Genetics, a company that has just emerged from declaring bankruptcy towards the end of last year as a new, leaner and meaner genetic research firm, and we'll hear more about their plans going forward, and it's great to see Kari back here in Boston. Last but not least is Dan Vorhaus. In case we have any argy-bargy on the panel here, we've brought a lawyer along just to mediate the proceedings. Dan Vorhaus Esquire is an attorney with Robinson, Bradshaw, and Hinson, and if you're scratching your head thinking, what the hell is he doing on this panel? Dan is the founding editor of the Genomics Law Report, which is, I think, an absolutely indispensable blog and information resource on this entire field. It really is absolutely must-read information in this. He's also in town because he's intimately involved with George Church's Personal Genomes Project, and we'll hear a bit more about that. So please join me in welcoming our four guests. Kari, I'm going to start with you. What is up with this volcano? Please tell us what is going on. And
this volcano is actually has erupted several times in history. In 1821, in 921, and 500. This is a relatively large eruption now, the ones that has caused the ashfall in Europe. It is adjacent to another volcano that is much more powerful called Katla. When that erupted in 1785, it caused climate change and failing of crops both in Europe and the United States. So this is a serious stuff. However, we were wise enough to direct our volcanoes towards others, not towards ourselves. So I could I could easily fly from Iceland to here the other day, while some of my friends were trapped in England, in Ireland, in France, etc. Well, but it's a bit scary.
Reassuring to know this is just a baby volcano by Iceland's
standards. It's sort of a teenager.
Yeah. So I mentioned Decode has had a pretty turbulent time in the past year. I think its issues with it are well known, but you have emerged from bankruptcy. This is the first opportunity I've had, certainly, to hear about how things are going. Decode has and continues to do absolutely phenomenal research, as we all know, in genetics, not only of rare diseases, but of common diseases. You have a diagnostics division. You're also putting drugs into the clinic, and obviously some of those activities have had to be,
originally when we founded Decode in 1996, the goal was to use genetics to develop diagnostic instruments. And at that time, simply the technology didn't exist to reliably make discoveries that you need to turn into diagnostics. And you could argue that the company was founded about 6 years too early. And during these 6 years, we collected some sort of legacy problems, we collected some debt. And then what sort of toppled us over was when Lehman Brothers went bankrupt and went away with significant amount of our money. During these difficult times, we continue to do research, and actually I'm very proud of the people in the company. They continue to do phenomenal research even during the most difficult of time. We have now emerged out of Chapter 11. We have shared the drug discovery resources. The drug discovery, in many ways, the entry into drug discovery was a way to deal with the fact that it was impossible to put together diagnostics from the resources, from the technology that we had then. But now we have shared those resources. We are focused on diagnostics. We are putting together individual diagnostics for individual diseases, a pharmacogenomic test. We launched the first sort of consumer genomic service that was launched, and that is still out there. We are entering into a new phase in our discovery that's going to be based on sequencing of whole genomes. And because of our understanding of the structure of the Icelandic population, we only need to sequence genomes of about 2,500 Icelanders to be able to impute the sequence of the entire nation down to a frequency of about 0.1%. And the beauty of that is that the expectation is that when you go into the sequencing, we are going to pull out relatively rare variants with larger effect, not terribly rare and not with terribly large effect, but with greater effect than we see now. And when you're working with rare variants, you need a large number of cases, and we will get a whole nation. In addition to that, because of our founder effect, the rare variants in Iceland are going to be a little bit more common than elsewhere. So I believe we are in a really good position to continue to teach the rest of the world how to do genetics.
Right.
How about that for a humble statement?
You're known for your humble statements. Dietrich, let me turn to you. As I introduced you, you are the founder and creating a very ambitious undertaking called the Ignite Institute for Individualized Health. I wonder if you would share with us what your vision for this institute is. It's much more than just a sort of a research institute, isn't it?
It is. It's an iteration on an institute we built in Phoenix, Arizona, where I was the director of research, called TGen, where we really tried to use the latest technologies to accelerate new drug and diagnostic development to the commercial sector. And this new effort is really predicated on building the foundation for deep molecular subclassification of chronic complex genetic disease, to try and drop out pure molecular subunits of those common diseases that we're all going to get and suffer from, and then embark on a new wave of exposure epidemiology. So, for example, does heavy metal exposure cause a subtype of autism spectrum disorder? And then with that companion diagnostic in hand, embark on a new wave of drug development. And I think it's reasonable to assume that if you start with a pure class, that you'll have very high efficacy rates emerging out of that. And then continue to chaperone those results through the commercial sector and into the clinical sector in an abbreviated time frame.
You've also announced a partnership with Life Technologies, the company formed by the merger of Applied Biosystems and Invitrogen, where you're going to purchase 100 of their latest top-of-the-line genome sequencing, next-generation sequencing machines, which is immediately going to catapult you into one of the most high-throughput sequencing facilities in the world. So what are you going to do with that firepower?
Well, I think in a nutshell, at the end of this year, the price point at volume for sequencing a full genome will start to approach about $3,000. And that's the price point that we saw the high-density genotyping market start to light up in the R&D space. So that's when the first whole genome association studies started to be done on the AFI 500K platform. And so it's our expectation with our backlog of case control cohorts that we did on the high-density genotyping platform, we would need a throughput to sequence. With this throughput running at full bore, we can sequence about 7,500 genomes a year with really nice high accuracy. We really want to be able to go back, rip through all of those whole genome association studies and capture the totality of heritability for these common chronic complex genetic diseases, which, as you know, has been sort of the missing heritability, as Dr. Collins calls it, is something that has hampered our ability to efficiently and effectively do pre-symptomatic diagnostics for these diseases.
And just briefly, you were going to locate this in Northern Virginia, right next to, obviously, Washington, D.C., which would seem to be a useful place given the issues that are involved, not just scientific, in personalized medicine. Is that still the plan? Because one of your partners there's been some news recently about them potentially not taking part.
It still is the plan. We strategically picked Washington, D.C. because we felt we needed to be close to the regulatory bodies so that they could understand what we were doing and we could educate them as to how to turn on, for example, multivariate pre-symptomatic probabilistic diagnostic tests. It's non-trivial to regulate those types of indications. Likewise, on the policy and economic modeling sides of turning on these new tests that'll fundamentally change the way we deliver health care. How do we pull the business levers, for example? How do we make the economic arguments to the payer communities, which all have a footprint there that they should reimburse healthy individuals for expensive genetic tests? It's a big raise. We're raising $250 million in a down economy, and this part of the region, specifically Northern Virginia, has never seen biotechnology before, and so it's just taking a little longer than we thought it would.
Okay. Jamie, let me turn to you. Patients Like Me, a company you founded, you're the chairman of it a few years back. Many people here are probably familiar with it, but I suspect there are many people who may have heard of it but aren't quite clear what the goal is, what the basis is. And I'd like you to address them and the people watching via the web. What is your overarching goal of building this community called Patients Like Me?
Well, there's two versions. So, the one is how the idea really comes into existence, and the other is the one that we say now to make ourselves sound smart when we had the first version happen. So the first version was I was running a clinical trial in ALS, and we were looking at data collection paradigms. This was about 7 years ago or so, and how do we get the information to patients? How do you collect the information? Can we make it more effective? Recruiting, all the variables, and then my wife left me. And I was, because obsession is a very bad marital trait, and I was online dating. So I was looking at Match.com, shopping for phenomes. And I actually did find a phenome, and we're now together and have a baby. So it was a very effective tool for me. But I was looking at the variables: dark hair, thin, tall, the whole thing that we were looking at, thinking these are very similar to clinical assessment tools. And if I were a patient, I would want to find another patient just like Liza, who's my wife. But now that was actually true. That really was what happened. We sort of intersected those things, and the idea came from there, and we thought about how to execute it. But I think that the other story, and I think it reflects similar journeys that Kari and Dietrich just described, was I was doing research, and we were using many of the tools, AFI and collaborating SNPs and technologies to understand ALS as a disease. And I had this observation that the tools were becoming free. Cost of the genome's going away, cost of RNA is going away, cost of proteins going away. It's a little late, but it'll get there. And I kept thinking, this is looking a lot like the early days of the software business, and I don't want to be a hardware guy because they don't look like they're doing very well. So the question is, what are we going to operate this network on? And the question everyone's asking now is, where do I do my first 7,500 sequences? Where do I do my first information? Because you want to understand where it's meaningful. And in our case, I thought that we basically know jack about disease. When you think about what we use genomics for, we use it for profiling in oncology, and you're looking at what the phenome is. Did you die or not at 5 years? Do we know anything else about the samples? Basically not. When you look at a disease like ALS, were you diagnosed? But do you know anything about the progression rate or the other symptomology of the patients? We have almost no information that we're computing against. And so the idea of envisioning a phenome that was capable of meeting the complexity of the genome came out. And the last thing I want to add in here, and this is about personalized medicine, there's always this disconnect between we're going to have these tools that we'll use on populations, and suddenly the meaning to me will pop out. But never showed me the first application. We can use it for targeting on oncology drugs and determining whether or not you're going to metabolize drugs in the right way. But the real application is, what we're really talking about is probabilistic medicine, probability-based medicine. I want to know what's going to happen to me on every variable that is meaningful to me in the future. And we have to begin to solve that problem. And I think Patients Like Me is built to solve that problem. What is every meaningful variable in our life, including genetics, but only once they've been validated, and all the other phenomes, and then the ability to model on a probability basis the future state of that individual, which can then be used to feed back into population studies for discovery.
I just want to quickly follow up before we turn to Dan. So you have communities for patients with serious, perhaps a dozen serious diseases. Who gets the benefit? Obviously, patients can compare themselves to many other people anonymously around the world, but in total, the sum of this information also has value. I wonder if you could talk about the two sides of that.
Sure. So, at the simplest level, you could say we're Facebook for patients, attached to a huge battery of rigorous clinical assessment tools that allow you to, measure phenome or outcome over time. The two tricks are that it's fully open. There is no privacy in our system. If you go to our website right now, click on symptoms, click on sexual dysfunction, you can find the sexual function level of 18,000 people at this moment. So that's available, and you can see about 20% of them because they're sharing their data publicly, not just within our the dark internet and inside our platform. But the other thing is that we aggregate that up into real-time evaluation of the side effects of drugs, real-time evaluation of every symptomology and normality in the context of each disease. So, and we have now 25 drugs at over 1,000 patients. They're approaching registration levels. We track 10% of newly diagnosed MS patients, ALS patients. We have 10% of our largest drug, Copaxone's, worldwide sales being monitored real-time on the platform now.
Great. Dan, last but not least, let's turn to you. So I mentioned that you're closely involved with the Personal Genome Project, this project that George Church started 4 or 5 years ago. We heard yesterday in the keynote from John Halamka, who's PGP number 2. Talk to us a little bit, because I suspect there's still people who don't quite understand the overall overarching purpose and goals of this ambitious endeavor, which has 10 named individuals, but has IRB approval to pull in 100,000 individuals. So what is that about, and what is your role with the organization more specifically?
Right. Well, it's in many ways similar to what Jamie was describing with Patients Like Me. I think there's a lot of shared vision between those two groups. The Personal Genome Project is really about sort of a form of next generation public genomics research. So it's trying to develop these fully integrated, rich data sets where you take not only genomic information, but you combine that with phenotypic information. I don't know if we're not collecting Match.com profiles yet, but potentially sometime soon. But really,
Facebook app, right?
Yeah, exactly. But combining all of that information in a way that is linked and integrated and then made publicly available. So one of the most novel features probably of the Personal Genome Project, and that generates a lot of discussion, is the fact that someone like John Halamka comes up here and he's identified as PGP number 2, and you can go on the website and you can see his, right now I think you can see his AFI data and probably his exome data as well, and moving in the direction of whole genome sequence data. And so my involvement, actually, I don't have the scientific background that everyone else on the panel here has. My involvement is on more the LC side, so ethical, legal, social implications. That's how I was recruited to help with with the project, because it obviously addresses a very unique set of challenges that I think we're seeing become more and more common as models have sort of moved in this direction over the past 5 or 6 years since I've been involved with the project. And so, generally what I work on with the PGP, on a pro bono basis, is helping them think through a lot of those issues, working on the informed consent agreements, and all of the other sort of ancillary issues that have come up in the course of this project and will continue to come up. Like you mentioned, 10 enrolled, working on the next 100 right now, sort of as we speak. IRB approved up to 100,000, so it's an exciting project, and it's going to be big.
How important is genomic privacy? There's one person in this field, Stan Lapidus, the founder of Helicos, once said to me, I'm much more concerned about my financial privacy than my genetic privacy. He's also a volunteer in the PGP. What are some of the issues around keeping this information private? Is it going to matter in a few years' time?
Well, there are plenty of people that share Stan's viewpoint, and I think those are the kind of people that tend to be attracted as potential participants to the PGP. But there is a lot of uncertainty about what does it mean to publicize my genetic information. Part of that stems from the fact that we really don't know everything that sort of information will be able to tell us. We don't know what the limitations of that information are. We don't know how it can be used and how it can be misused. And so one of the challenges that we are constantly facing with the PGP is trying to think through all the different risks of participations, both the known and, more importantly, the unknown risks, or the ones that we only sort of suspect but are not yet manifest, and convey those to potential participants, in a way that allows them to give truly informed consent to participate in something like this, because we really want to recruit people, but we want to make sure that they come in with their eyes open, and that's just a very difficult thing to do given where we are in the development of these sorts of research projects.
Kari?
Can I just comment on this? The basic idea behind Decode was this data integration that these two gentlemen have been talking about, is to integrate the data of an entire nation, and we have done that. And it's not just about sequence variants. Up till now, through genotyping, within the next few weeks through sequencing, but and not just on genotypes and phenotypes, but also on population structure. And the reason that we can go from 2,500 sequences to 320,000 sequences is that we know exactly who everyone in the country is related to everyone else. We can take 2 random individuals in Iceland, and we can, instantaneously determine which pieces of DNA they share identical by descent. And that is the reason we have been able to make the progress that we have done in genetics and will continue to do so. The data integration is a key.
Very good. Let's take a question from the audience up here on the let's get you mic'd up. Okay, go.
So my question is actually related to this, though maybe twisted in a slightly different way. The elephant in the room has always been, what are the insurance companies going to do with this information? That's always been perceived, publicly as the risk. And so I guess my question, maybe to both of you, so for the Decode, are you going to make that information, once you have the sequences available, public, such that a particular individual could go and look up what their risks are? And for the PGP, I know that the intent there is to make all the information public. And so I guess I'd be interested in your opinions as to, if we have enough public information, enough public sequence available, will that intrinsically mitigate those risks? Because once all that information is available, everyone's going to have some kind of genetic, probabilistic potential for disease, and it may be that when you aggregate that across the population, if we have enough public data available, that will intrinsically mitigate those risks, which is what's being talked about a lot in the public domain right now.
Dan?
Well, the first answer to your question is that in the United States, at least, we now have a law that addresses that. The Genetic Information Non-Discrimination Act, or GINA, was passed in 2008. It took about, I think, 13 years to wend its way through Congress, but it was finally passed, and that does address some of those issues specifically. It addresses employment discrimination based on genetic information, which includes family history. It also addresses insurance discrimination, but only for health care insurance. It doesn't address long-term care, disability, and life insurance. So, partly I think there's a legislative and there will be a regulatory response to address some of those fears. I agree that they have been generally fairly widespread amongst people that have been asked, but not well documented as far as actual abuse or misuse of genetic information by insurers. I think longer term we have a question to ask ourselves about how is the insurance industry really going to work. Is the concept of insurance fundamentally consistent with telling insurers that you cannot take into account any of this information when you're insuring people? We understand that there's some really strong sort of moral objection to having people with they got a bad draw on the genetic lottery, or however you want to frame it, and then they can't get insurance, or it's too expensive to get insurance. But is the right approach to really require insurers to sort of bury their heads and ignore that information while individuals have access to it? I don't know, and I think that's something that's going to play out over the course of the next decade, as more and more people have access to this information. And GINA and PGP and putting the information in the public domain is going to help sort of spur those conversations. But there's a long way left to go.
But it is complicated with the insurance because the insurance industry is there to spread risk. And if we weed most of the risk out by the use of the genetic information, the use of the insurance companies becomes relatively little. Those with very, very high risk of bad diseases are going to be charged very, very high premiums, and it may not even be worthwhile for them to buy it. And those who have very little risk have very little incentive to buy the insurance. So I think that the insurance industry will have to figure out how to intelligently use it if they will be allowed to use it. When it comes to sort of public domain placement of data, you see, we are in the business of making discoveries, and we do not want to have a high barrier for people to participate. And we definitely don't want to place our data indiscriminately into public domain. We do not want to encourage people to do that. And there is a law in Iceland based on the directives of the European Union that makes it illegal to do so. And I actually think there is the wisdom of NIAs to demand that those who get funding from NIAs to do genetic study, they place both phenotypic and genotypic data into a sort of public domain database is in violation of a sort of this fundamental concept of trying to protect the participants in research to make more likely that people will participate.
Jamie.
That contrast is really interesting because I think what we're struggling with, and I think there's two sets of rights that are being violated here. One is there is a right to privacy, so you should not have society force disclosure upon you. But there's also a right to free speech. And there are laws in the US and laws in Europe that essentially prevent an individual from aggregating their data with other individuals in a project basis. So we have a situation where there are laws that sort of would say, well, I know you're a reporter for the New York Times, and I know all these people volunteer, but you're really not legally allowed to talk about that. And I think the question I'm interested in, and I love an invention of the PGP, by the way, which is just brilliant, which is the idea of consent at the PGP is not the BS consent that we all use in industry, which is, did you sign away your legal right to sue me even though you don't really understand? But it's a true concept of consent, which is a test, which I failed the first time I took it. Now, I'll disagree on the answer to one of the questions, and George and I can fight about that later. But you have to pass this exam that shows you understand the consequence. And I think the probability of getting through that exam and having not understood the consequences that they thought through brilliantly at the PGP, releasing your genetic data, is very, very low. So this question, Kari, I think the question will be interesting. Will the open systems, which there are clearly 10% of any society that's willing to say, hey, I'm naked, I'm good, I'm there. versus the 10% that say, don't you dare tell anyone, my eye color. And if you're operating to protect the most restrictive secret 10%, I don't like the word private, versus protecting the rights of the open 10%, I think the open 10 is going to win. I think that they're going to provide enough data for us all to figure these problems out in a really powerful way. And the power of open data sets versus ones where you can't drill to the individual level is just so limiting. I think it's just going to happen.
I wholeheartedly disagree with you.
I know.
And let's just compare what we have discovered and you have discovered. We have been very successful with a system that is designed to protect the people who participate. We are working with participation of a very large percentage of a nation, all right, that is very proud and to a certain extent very private. And I think that privacy is something that we should respect, and we can do extraordinarily powerful research in spite of protecting people's privacy. There are all kinds of ways to do that. For example, we are working with a third-party encryption system that allows us, given permission by our data protection authorities and by ethics committee, to go time and again to the same people. But we never need to disclose anything, and actually just depositing. I can tell you, one of our good people sat down at the computer the other day and looked at the HapMap data, and he could, in few minutes, figure out that one of the members there was half Icelandic, and it was a really easy stuff to figure out who this person is. And I think that to say that it is just enough to anonymize sequence data, etc., and put it in a database and nobody can figure out who it is, that's just an illusion. All right? And we have to, if we want people to continue to participate freely in our research, we have to be able to provide protection of the privacy.
Okay, I'm sorry, Jamie. Let's Dietrich, Dan, and then another question, and then Jamie, and then another question.
I agree that payers are the elephant in the room, but not because of discrimination issues. We know how to keep data private, sensitive data, and you all know how to do that better than any of us geneticists. I think the elephant in the room related to payers is adoption of reimbursement for sequencing the genome and interpreting it across an individual's life. There's clearly value in the human genome related to medicine and health. Otherwise, the NIH, the National Institutes of Health, wouldn't have spent billions upon billions of dollars to sequence it, develop technologies around it, and build a knowledge base of correlations between bases in the genome and disease. So there's value there. But why haven't we seen it applied in a broad-based way and mined across an individual's lifetime? You can do newborn screening with a sequence. You can do pre-symptomatic risk assessment for complex trait. You can do monogenic diagnostics. You can do carrier testing. You can do pharmacogenomics in a single-shot assay. So since this panel is named The Future of Personal Genomics, I'm going to predict the future here and say we're going to get convergence at the point where the price point of sequencing a whole genome equals the price point of sequencing a single gene. So instead of going off to Myriad and getting a BRCA1/2 test at a price point of $3,000 plus, if you can get your whole genome sequenced for the same amount of money and add value continually over time by annotating that genome with our growing knowledge base, that's the point we're going to see payer adoption. That's the point where we're going to see convergence of this whole space. And I anticipate that's no more than 2 years
just
off.
One little comment. There is truly reluctance on our society to pay for population screening. There's no question about that. There is some reluctance by payers, but the biggest reluctance today is by the medical profession. The medical profession is fairly afraid of this, is reluctant to adopt this, and is fighting against it. And that's amazing.
It is amazing, and I think you're seeing, consumer drive, especially when they get sick, when they get cancer. They suddenly want every molecular test. They want their cancer tumor sequenced. They are forcing their physicians to understand this. We're seeing, at the federal level, we're seeing people struggling with, oh my God, in 2030 we're going to be spending 40% of our GDP on health care. And suddenly they're thinking about prevention and efficiency, and it boils down to preventive genomics. So I'm sorry to go on, but I agree with you.
No.
Dan, did you have a comment? And then we'll take
well, several, but I'll try and pick one. I guess I'll maybe just so we move forward instead of back. I'll add my own prediction, which is, I think Dietrich's right. about when we're going to start to see that convergence, when we see the cost of sequencing, and not just, let's clarify, not just sequencing, not just generating the raw data, but when you get to $3,000 with some interpretation and annotation, so it's comparable to what Myriad is doing right now, looking through their database of variants. That's when you're going to start to see a lot of that convergence. And I think what we need to see moving beyond that, and what we're going to get, is moving away from patients and genetic data to individuals and genetic data. And I don't know what the proper term is. I go sort of back and forth about this, and I think we need a better term. But to move beyond patients as diseased, individuals with a manifest disease state, all of a sudden wanting to have this full genetic workup and
individualized health.
Right. So individualized health instead of personalized medicine, because with this implication that somebody needs to be sick, before they go and get this information, I think that's where we're going to see change. We're going to move much more broadly beyond that into something that is much more, over the course of an individual's lifetime, much more holistic.
We've got about 10 minutes left, so I'd love to see a few more questions from the audience if we can get them. Yes, please.
Well, did you say 2 years on that convergence? Do you think that's a reasonable?
Yeah, I think so.
Well, that's terrific. I do come down on the side of privacy of the genomic data, but in a sense, if the individual knows their odds of various diseases, and the insurance company doesn't, it weights the game, right? It seems that the insurance companies really wouldn't be able to survive if everyone who wasn't going to get sick knew that, and then they wouldn't buy insurance, they wouldn't pay into the pool, et cetera. So for the individual to know their odds and nobody else to know it, while for the individual, I kind of like that odds, but it'll break the system. And so, I think there's really going to have to be, a way for everyone to contribute to the health of the population, and without being able to use their own odds for their own financial benefit.
I have a quick answer to that, and then I'll let the rest of the panel feed in. But number one, if you're hedging your bets across the population by delivering this information to individuals, by and large, I think it's to keep them healthier. It's not to, have people just drop out of the system and you know what I mean. So,
but is that how they're going to use it? That's would be the goal, I would think. But
yeah, I think the other aspect of it is that as you look across your portfolio of pre-symptomatic risk, and we've looked across hundreds of people now for dozens of chronic conditions, an individual on average has one or two chronic conditions for which they're at increased risk significantly over the general population. And so you're sort of reshuffling everything, but I don't think you change the economics.
Most of them have only one. It's rare to see a very significant risk for two of them. But what is interesting here is that this ability to impute the sequence that we have, you only need to genotype about 2% of the American nation, and you will be able to do the same kind of imputation as we can. So it's not only that there are going to be people who come and they want to have the genome sequenced or want to be genotyped. We are also, whoever, be the big bad government or whoever, will be able to impute the sequence and therefore get at least a lot of information about the population, although not the individual.
I just want to
Dan, then Jamie, quick.
Really quickly. This when we talk about genetic information in insurance, there's this tendency for this almost genetic determinism to creep into the conversation. People, think that individuals or insurers are going to get this information and then be able to pinpoint who's going to be sick, who's going to be healthy, who needs insurance, who doesn't. Obviously, it doesn't work that way. We're still figuring out the extent and the accuracy of the predictions that we can make. But even if I had every single protective variant out there, doesn't mean that it wouldn't still be a good idea for me to have health insurance and for me to buy health insurance. Yes, you've got an information asymmetry that's going to need to be addressed in some sort of way. I don't think Gina's a perfect answer to that, but it doesn't mean everybody's going to leave the insurance system.
This is just the epidemiological data indicates that the contribution of genetics to risk on most of the common diseases is about 70-75%. And that is a pretty large percentage of the risk. So although, yes, they will not be able to say that you have it most definitely going to get a disease, these percentages, these probabilities become extraordinarily meaningful in the context of the insurance business.
Let me
No, there's something I want to hit on this because I think we're focusing too much on genomics. I mean, we're really talking about the transition to a society where we can compute probabilities for individuals on much larger bases. And, we can argue about the assumptions of the meaning of the whole genome sequence increasing our ability to predict more effectively and how much is in that. And quite frankly, it's going to wash up against the same thing that SNPs had, which is it just wasn't that predictive in the first place. And, hype will reality, and then it'll integrate through another curve and it'll get better. But the reality is we know right now enough, if we impute the information we know about each other, to make some very powerful predictions. And those tools are being used already by corporations, governments, infrastructure in the information war, the individual versus larger systems.
I wholeheartedly disagree with the man on my right-hand side. I can tell you recently, just as an example of the power of the genetics and how incredible impact it has, we have a big project on the genetics of dyslexia. And just the other day, we pulled out a sequence variant that has enormous impact on whether or not you're a bad speller. And actually, if you are very bright, your IQ is very high, the impact of this variant is much greater. So if you take out those who spell badly because they're stupid, this variant accounts for a very large percentage of it.
I'm trying to decide whether you're imputing my genome at the moment.
No,
but, but the real question here is, Kari, I think we're both agreeing and disagreeing. I mean, we have to figure out this. Genome is a point part of this conversation, which is that how do we deal with a society that can use large-scale computing and information to predict the future? And it's not, right now, how long did your parents live?
In his simplest form, and therefore most easily to digitalize and analyze. Okay. That's the only thing it is.
Well, let's hold it there, please, because we're in the rapid-fire round part of the discussion now. So we've only got maybe 5-ish minutes left, so let's try and get these last few questions in. So the lady here, please.
Yes, I'm going to try to get you a little bit off topic there because you've already discussed individualized medicine. And my question is in terms of the other elephant in the room, which is education. And what is it going to take as societies across the world to educate both the layman people and typical people that go into the doctor's office as well as the doctors themselves? Because basically the probability is something to which all of us will have to address as this information becomes available. So right now people with breast cancer can decide to have mastectomies or not. What is the trigger when there's environmental factors that we don't understand or lifetime experience and exposures? So where do you see this moving as we're propelling into $3,000 genomes? Where do you see this going so that we can manage it as a medical community?
We'll start with Dan.
Yeah, this is a big elephant in the room, and particularly for the PGP. I mean, Jamie mentioned that he didn't pass the screening exam the first time, and you can retake it, thankfully. But there is an incredible, bias in the PGP's model as far as who it is able to recruit because of this tremendously high bar that it sets. And that starts with education, the background information to make sense of this. And as this moves out into broader research studies, as it moves out into doctors' offices, not just in this country but around the world, the education issue is a huge one. And understanding, Kari can sit here and and understand what his relative risk is or what his lifetime risk is, and fully comprehend that. But most people can't. Even probably many people in this auditorium, let alone most people out there, who just need to go see their doctors and learn about this. And so that is a huge problem and is going to be one of the, I think, limiting steps for really taking this out much more broadly into individualized medicine and into people's lives, is really being able to understand it. And it's not just the patients themselves, it's the doctors as well, and the people that, we have a tremendous, dearth of genetic counselors, for instance. I mean, there are sort of problems across the board here as far as making sense of this information and helping people, get access to it.
Any other quick comments from the panel?
I don't think this is a big elephant, because medicine today is largely based on assessment of risk, not using genetics but using other tools. So conceptually it is not difficult, and what genetics will do is simply give you numerical value to risk, that's all. And it's also extremely important to realize that medicine as it is practiced today is very poorly understood by the patients. and it's only marginally understood by the physicians. So the ignorance there is not anything new. You see, this isn't, when it comes to its very nature, fundamentally different.
But genetics carries a different expectation of understanding, I think, by both doctors and by patients.
It carries a different expectation of understanding by audience like this, but not necessarily by patients.
Did Francis Collins need to know, because of your test and your test, that he had an increased risk of type 2 diabetes to lose 25 pounds? Or should he just, again, there is an increased perception because of the, quote, precision, which is not as precise as we claim it to be, of the utilization of these tools and predicting outcomes that causes behavioral change. But that precision doesn't have to come from genetics. That precision is coming from genetics because we have a failure to measure that precision in the rest of the measures that are meaningful in healthcare.
You're absolutely correct. And we have another example of the same. We are talking about a serious issue. Don't laugh. Okay. We have another example. We have a good example for some cholesterol, which in many ways elevated cholesterol has very similar implications as being homozygous for the TCF7L2 variant. So this is nothing new. We have been working with this for years.
Dietrich, 10 seconds on this?
Yeah, I would agree that genetic information, I would agree with Kari that genetic information at its rawest form is just like an X-ray in terms of the pixels. It's just like a mass spec in terms of rolling all that data up for a physician and putting an asterisk next to it and telling them what they should do downstream of it. I would also agree, and we've seen this again across a base of hundreds of individuals, that the G word, for some reason, and I don't know what it is, has a different impact on people, and they do change behavior more than their doctor sitting there screaming at them, telling them they're fat, they got to lose weight. So it's different.
Okay. 2 final questions. Yes.
Okay. I'm on the open public end of the continuum. So could you just briefly comment on the social implications if my parents, my children, or my future grandchildren prefer to be at the secret, private end of the continuum? Is my consent potentially propagating out to people who would otherwise not be affected by my decisions?
Yeah, familial consent is certainly an issue. Right now, for the Personal Genome Project, you're required to seek familial consent only if you have a monozygotic twin. But it's something that we're certainly looking at. I'm actually participating in another research project where I've actually been genotyped, and one of the things that I did was have an extensive conversation with my family about what it would mean to publish this data in an identifiable fashion. And not everybody, at first blush was really, on the same sort of side of the openness spectrum that I am. And so that's something that is going to be, a challenge as more and more people have access to this data and more people want to, make it open and available, because what I want to do and my ability to make that information available is going to come in conflict to a degree with, my siblings, my parents, my children. The good news is we're still dealing in probabilities, and they diminish, very rapidly as you move away from the individual.
Yeah, Jamie?
I think we're going to be looking at that question in 20 years and laughing, because I think it's over. I don't think there will be. I think if you're thinking about the fact that every camera in 5 years will have a GPS and a transmitter to Amazon's cloud, and someone will be running facial recognition platforms on that. If I had an HIV test that I took over the counter and I got that diagnosis, I would go and type that into Google, and they would know, and they're a marketing company under no restrictions. And if I wanted to find it, I'd go type it into Yahoo Maps for the name of a clinic, and they would know the address I was going to, and they could impute it. So the idea that, we should just get used to now everything about ourselves, our future, our past, and our ability to modify that will be computed and known in 20 years, and it's just done. And everything else is just time, and you can choose when you want to go over that cliff.
Final question is from Mike Cariaso. Mike.
Hi, Mike Cariaso from Snipedia. I'm a little concerned, actually. I keep hearing this sort of mantra of reporting back probabilities, and I really think that it's an artifact of the way that GWAS work and the fact we're working on microarrays, that we're forced to impute so much and we're forced to rely on probabilities. But I really don't want to imagine that's the end game we're looking for, and I'm a little surprised that so many of you seem to be looking towards the day where you're communicating probabilities back rather than we've now found the causative mutation. That's, in fact, what you want to be doing. Probabilities are the information you look to return to users in the near term?
This is a fundamental misunderstanding Because what these sequence variants that confer the risk of common diseases do is in many instances just to put you on a normal distribution curve of physiologic function. And so when you're exposed to a certain environment that pushes you farther along that curve, you will develop the disease. The kind of mutations you are talking about are simply the Mendelian mutations in the coding sequences. They're rare diseases. They are not the diseases that are responsible for most of the public health burden in our society. So this is a mistake. There are not causative mutations in these diseases, only in the Mendelian phenocopies of them.
And even there's often a fluff factor associated called penetrance, which means you might not get it, and we have no idea why.
Well, actually, let's do it the simple way, by the way. It's not about the genome. You know, what city do you live in?
Wageningen, the Netherlands?
In the Netherlands. Okay, so your probability of being hit by a bus, which is probably your most likely cause of death given your age and status right now, is driven by whether you live in a city or not. And it is, I can't tell you whether you're going to get hit by a bus or not, but I can tell you whether you're more or less likely to based on whether you live on Kari's farm or down in the middle of New York City.
Are you saying that he would be hit by a volcano?
You already tried to get me, actually, on the way over here.
There's a very good chance of that, I think. Ladies and gentlemen, please thank the panel for a fantastic discussion. Thank you very much. Enjoy the rest of the conference, and we'll see you next year.